one way to create a lot of the same kind of object is make them self-reinforcing.
If that system can make itself, then it can persist in time, right? Because all objects decay, they all have a finite lifetime. Things that can copy themselves are very rare. And that's what we're trying to figure out is what are the causal constraints that close the loop. So there is this idea that's been in the literature for a really long time that was originally proposed by Stuart Kauffman as really critical to the origin of life called autocatalytic set. So autocatalytic set is exactly this property. We have A makes B, B makes C, C makes A, and you get a closed system. But the problem with the theory of autocatalytic sets is incredibly brittle as a theory, and it requires a lot of ad hoc assumptions. Like you have to assume function. You have to say this thing makes B. It's not an emergent property, the association between A and B. And so the way I think about it is much more general. If you think about these histories that make objects, it's kind of like the structure of the histories becomes collapses in such a way that these things are all in the same sort of causal structure, and that causal structure actually loops back on itself to be able to generate some of the things that make the higher level structures. Lee has a beautiful example of this actually in molybdenum. It's like the first non-organic autocatalytic set. Basically, like if you look at the molybdenum, it makes a huge molybdenum ring. I don't remember exactly how big it is. It might be like 150 molybdenum atoms or something. But if you think about the configuration space of that object, it's exponentially large, how many possible molecules. So like, why does the entire system collapse on just making that one structure? Mm-hmm. If you start from like, molybdenum atoms that are maybe just like a couple of them stuck together. And so what they see in this system is there's a few intermediate stages. So there's like some random events where the chemistry comes together, makes these structures. And then once you get to this very large one, it becomes a template for the smaller ones. And then the whole system just reinforces its own production.
How did Lee find this molybdenum?
So I don't know all of his history, but like what he's told me is he started out in crystallography. And, there's some things that he would just, like people would just take for granted about chemical structures that he was like deeply perplexed about. Like, just like, why are these like really intricate, really complex structures forming so easily under these conditions? He's just carried with him these sort of deep insights from these systems that seem like they're totally not alive and just like these metallic chemistries into actually thinking about the deep principles of life. Assembly theory came from him thinking about how these systems work. So he had some intuition about what was going on with this molybdenum ring.
The molybdenum might be able to be the thing that makes a ring.
They knew about them for a long time, but they didn't know that the mechanism of why that particular structure formed was autocatalytic feedback. And I actually think that paper is revealing some of the mechanism of the origin life transition. You should have a combinatorial explosion of the space of possible structures that are too large to exhaust, and yet you see it collapse on this really small space of possibilities that's mutually reinforcing itself to keep existing. That is the origin of life.